little. Welcome, viewers, to the chemistry laboratory. My name is Luke, and this is my fellow scientist, Angus. Today we will be performing a simple hydrogen pop test using magnesium ribbon and 2 molar of sulphuric acid. The combination of these two reactants creates an acid-metal reaction with the production of hydrogen gas and a precipitate in the form of a salt. In this case, the salt is a white salt called magnesium sulfate. Also, a small amount of water vapor is produced as a byproduct of hydrogen gas, which is the major product created when these two reactants combine and is the basis upon which the pop test works. The reaction between the heat of the flame and the hydrogen gas is a highly exothermic reaction, resulting in the squeaky pop sound. The reaction between the products alone is exothermic, as heat is created in the flask. In addition to this, since an element is taking the place of another element in a compound, the reaction is a single replacement reaction. The reactants consist of a metallic element, oxygen, and a strong acid, which upon detachment will split, with the detached sulfate molecule attaching to magnesium to form magnesium sulfate, whilst hydrogen detaches altogether to form a gas. As well as this, as explained earlier, a small amount of water vapor is also produced.
Firstly, the variation of the pop test, which we will be conducting today, uses water as the medium. This in turn makes it easier to determine when the reaction is finished and the gas is ready to be ignited by the light splint, as hydrogen bubbles are visibly displacing the water. This is a much more effective method as opposed to the test being conducted in the air, where it becomes harder to determine when the reaction is finished, as no water is visibly displaced. As you can see here, we have already prepared the equipment that we need for the test. The blue container of water is where we will submerge our test tube in water, keeping it facing downwards using the lower clamp on the retort stand. As you can see, the other clamp has been placed higher than the last, as it holds the flask upright, of which is connected to the container of water through a plastic tube with an 18mm stopper. This ensures that no hydrogen gas escapes, and that it travels directly to our container of water, making sure that the tube is directly under the submerged test tube, so that the bubbles can rise and take the place of the water. Before the reactants are placed in the flask to combine, ensure that a Bunsen burner, which is on a heat-proof mat, is alight, and that the splints are in ready supply. Make sure that the whole of the Bunsen burner is open, so that when lit, there is a safety flame. From here, turn the hole so that it is half open, and the flame turns a blue color. After placing the reactants in the flask, the reaction should quietly take place. Within about 20 seconds, all of the water should be displaced from the test tube, and only hydrogen gas should be left in its place. Light a splint and ensure that your assistant scientist has loosened the clamp, so that the test tube can easily be taken out of the water.
When lifting the test tube out of the water, keep it inverted. As the water drains from the test tube, the surrounding air will enter and mix with the hydrogen gas. Since hydrogen is less dense than air, it will remain at the closed end of the tube, provided the test tube remains inverted. Now, put the alight splint near the bottom of the flask. The resulting sound should be a squeaky, pop-like sound.
In summary, Hydrogen is a colorless, odorless gas. The squeaky pop test is an exothermic, single replacement reaction which demonstrates that hydrogen gas is created when most metals come in contact with an acid. The squeaky pop noise is created when detached hydrogen molecules in a state of gas burn, and therefore its existence is verified through this experiment.